Bojo, welcome to Wahsa Distance Education's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live, you are welcome to call the Wahsa studio where you can ask questions. The number is 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television through Bell Express View, channel 972. You are always welcome to join through the Zoom video. The link is available from me, your teacher, as well as from your DEC. Classes are scheduled on Monday through Thursday, 11 till 12 in the morning, and we are now wrapping up week 4 of our 9-week course. A reminder of what work to submit for marking. The support questions, the ones marked with the pencil icon, are not for marking. You decide which ones and how many of them to do. If you are understanding a concept, feel free to skip the questions. Don't spend your time on something that makes a lot of sense. If you need more practice because something is challenging, let me know and I can send you more practice. The answers are in the back of your booklet, so check your work to make sure you're on the right track. However, mistakes have been found. So if anything isn't lining up, let me know and we can check to see if that's an error in the key questions. Those marked with the key icon are the marked questions, the ones to submit. So please do all of those questions and show all of your work, all of your steps in your thinking so I can give credit for all of your understanding. If you only give me the answers and you've made an error that's a calculation error or something small, I can't only take part marks off if you only give me the answer and the answer is wrong. So show all of your work so that I can give you the credit for all the work that you do understand. In order to submit your work, there are 3 different methods you could use. The first method is to scan and send your work in electronically. You can scan your completed work in with your smartphone if you have one. The iPhone Notes app has a scan function and the Android Google Drive app has a scan function. If you need help with learning how to do that, let me know and I can help you. If you don't have an iPhone or an Android phone and you just want to take pictures, that's fine too. Send your work to, you can either send it by email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street at our side entrance. We're the big red building next to the post office, and there's a small white mailbox that you can put your work in. We are continuing to work remotely, so it might take me a couple of days to get it, but I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work in through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions or concerns, please contact me. My email is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can get a hold of me through Facebook at bslatewahsa. You can call in the main office and leave a message for me and I can return your call. The number is 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday to Friday, 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. Connecting with me through social media, my Facebook and my YouTube are both under the name bslatewahsa. So you can find me on Facebook and subscribe to my YouTube channel, and then I upload the recordings of these videos every day, and I share them on Facebook, so you can find them there or through my YouTube channel. There's also short videos in my YouTube channel that explain common errors or confusing concepts, some reminders or refreshers from previous courses. So that can be a great place to access if you're struggling with something that isn't directly in our course, but it's just a skill that you need to do things that we're doing. Math is a really visual subject, so being able to access the videos is going to set you up for the most success. either coming to the live to the Zoom lessons or watching the YouTube replays is really going to be the most helpful. If you don't have access to the internet, but you do have access to a computer, let me know and I can send you a USB key of all the recordings. All right, we're on day 15 of our course, and today we're doing a Throwback Thursday, focusing on lessons 9. I know that this has been a short week. We've only had 2 days of new lessons, so why are we reviewing already? Well, as always, we know that the forgetting curve means that we forget information fairly quickly. We don't retain it over the course of time without reviewing it. So every time we review, it helps us remember it more, be able to access that information more quickly, and we also forget it less fast. Slower, I guess, is what less fast is. So recapping things is really, really useful. It means that when we get to the final exam, we're not having to relearn everything that we did at the beginning of the 9-week course. It should be a little bit easier to access. So even though we've only done a couple of things this week, we're going to continue with our Throwback Thursday to touch on the previous weeks, as well as dive into a little bit deeper on this week's topics because they were very full. All right, let's activate our brains with some mental math. We know that we don't love the concept of mad minutes, where it was a stressful time-based tests that didn't actually teach us any of our arithmetic facts. Instead, we focus on developing strategies that are transferable and that we can use in various situations. So today's question is 8 times 15, and we're using the strategy of making a landmark. So for this question, my 15 times tables were not ones that I was told to memorize. So what I'm going to think about is I'm going to say, okay, well, 8 is really close to 10. So I can do 10 times 15. I know what that is because anything times 10, we shift up by place value. So we often say we add a 0 at the end, but really what we're doing is we're increasing it by place value. So 10 times 15 is going to be 150. But if I did 10 times 15, that's 2 more groups, right, than 8. Because right now originally we had 8 groups of 15, and we did 10 groups of 15, which is 2 more groups. So I need to take away 2 groups in order to figure out what 8 times 15 is. So what is 2 groups of 15? Well, that's double 15, so that's 30. So if I do 2 groups, if I kind of think about, well, if I'm kind of subtracting 2 groups of 15 away from 10 groups of 15, then I'm subtracting 30 from 150, and that's going to give me 120. So 8 times 15 is 120. And that's how you can use a friendly number of a landmark when you're multiplying. It can be tricky because you have to remember that you are taking away 2 groups of whatever you're timesing by. So you have to remember that you're not just taking away 2, you're not just taking away 15, you're not just taking away 8, you're taking away 2 groups of 15. So that can be tricky, but it also can work really, really well in some situations. All right, let's recap what we've done so far. So this is all the way back to the beginning. We're going to keep refreshing to keep remembering the whole course. We'll spend more time on the newer concepts, but just a reminder. So lesson 1 was the transformations of quadratic functions, how we shifted things. Lesson 2 was polynomials and factoring, so it's multiplying binomials and factoring binomials. Lesson 3 was solving and graphing quadratic equations, so looking for the zeros. Lesson 4 was the exponent laws, so your multiplication, division, power of power laws, things like that. And lesson 5 was your simple exponential equations, so understanding what an exponential graph is and function and what the equation looks like. Then lesson 6 was simple interest in linear growth. Lesson 7 was compound interest in exponential growth. Lesson 8 was compound interest with compound interest formula. Lesson 9 was loans and RSPs. That was new this week. And lesson 10 was buying new and used vehicles and the vehicle costs. That was also new this week. So let's look at the highlights. We're going to start with what was new this week and then do small recap of the other topics. So the loans and RSPs, the highlights of lesson 9. So loans are borrowing money that is paid back through equal payments over a set period of time, including the interest. Payments are calculated according to how much we want to borrow, or how much we can borrow is calculated according to the payment we can afford. RRSPs are a savings plan for people who earn an income. You pay regular payments once you retire, and we know that investing earlier earns more in the long run. All right, lesson 10 highlights. So buying new and used vehicles and the costs. So buying a new vehicle, we learned how to calculate the monthly payment and how to complete a buying a used vehicle. We calculated the depreciation rate, the value, so the value of the vehicle after it's been used. And the cost of owning a vehicle, we calculated the fuel costs as well as the monthly cost averages, which include fuel, maintenance, insurance, and license fees. All right, a reminder of what Unit 1 looked like. So lesson 1, the transformations of quadratics, was where we had A tells us the opening direction, H telling us the horizontal shift, and K telling us the vertical shift. Lesson 2, polynomials and factoring, where we had expanding meant that we were multiplying according to the distributive law, and factoring meant that we were finding what two binomials would multiply together to result in the trinomial product. Lesson 3, solving and graphing quadratics. This is when we said solving a quadratic means what values of x result in y equaling 0, and zeros are the y or the x-intercepts are what it means to solve a quadratic. Lesson 4, the exponent laws. So we had multiplication means that if you're multiplying something with the same base, then we add our exponents. If we're dividing something with the same base, then we subtract our exponents. When we have a power of a power, then we multiply our exponents. We have a 0 negative, it always equals 1. When we have a negative exponent, then we have the reciprocal of the base. So we do 1 over whatever our base was. And then lesson 5, simple exponential equations. We knew that it's a very fast change, either as a growth or a decay, getting bigger, getting smaller. And our formula is y equals a times b to the exponent x. Our variable has to be, our changing variable has to be in our exponent. And that was what we did in Unit 1. All right, in Unit 2, we have our simple interest was lesson 6. So the pattern increases or decreases at a constant rate. I equals PRT was our formula, and A, our total amount, is equal to our P, our principal, plus our interest. For lesson 7, we were compounding interest, which is exponential growth. So the pattern increases or decreases at a constant ratio. And our formula, sorry, my formulas aren't coming up and I'm not, my animations were off, is A equals P times 1 plus R over N, all to the exponent NT. And our interest is calculated such that, like our interest dollars is calculated such that A, we take away P from A, our principal from the amount that we calculate. And then lesson 8, our compound interest formula. So this is where we had word problems where a situation must include the word compound. We were rearranging our formula to find the principal, the interest rate, or the time. And we had to use the nth root and the guess and check strategies depending on what we were finding. All right, so that's what we've been doing so far. That's a lot. We've done a lot. We're actually halfway through the course, halfway through all of the lessons. So it's jam-packed. So now we're going to do some mixed practice where we're going to have various questions, but we don't know which unit they're from, which lesson they're from. So we need to figure out, based on the question, which tools, which things that we've been learning about, how we're going to answer these questions. All right, number 1, Jill needs $1,200 2 years from now. How much should she deposit at the end of each quarter for the next 2 years in an account that pays 4% per annum compounded quarterly? All right, so this is a money question. This makes me think of our simple interest, compound interest, and our loans and RSPs. So It's not simple interest because it says compounded. So we know that it's not simple interest. We know that she needs $1,200. Okay. How much should she deposit at the end of each quarter for the next 2 years? So because it says that how much she's depositing at the end of each quarter, to me, that is that she's making payments. They're not monthly payments, they're quarterly payments, but she's making payments over 2 years. So as we talked about when we were doing the lesson, printing off writing out the how do I know which equation to use from lesson 9 would be really, really useful so that you can figure out which one. It's like you make your own little formula sheet. Again, for your exam, I'll include what the formulas are, but you need to figure out which ones for what. So here I'm making a payment. So that means I am doing something with either like a loan or an RSP. Because it's not a loan, I'm not borrowing money, so it's like an RSP. It's not exactly an RSP, but the same idea. So I'm contributing it to it, and I'm looking for the payment amount. How much should I deposit? So that means that the formula that I'm going to use, if I look at my formula sheet, is R equals, because we're trying to find the payment, AI, because I know the amount that I want, times the interest rate, divided by 1 plus I to the exponent negative n minus 1. Again, I don't have these memorized. I'm looking them up and deciding which one I need to use. So now I'm going to write beside it what my variables are to figure out what information I know and organize it. So R is our payment. That's what we're looking for. Our amount that we're going to have at the end is 1,200. Our interest rate is 4% per annum compounded quarterly. So 4% is going to be 0.04. Compounded quarterly means that I'm going to divide it by 4. And N is the number of time. So it's 2 years, but I'm doing it quarterly, right? I'm depositing at the end of each quarter. So after a fourth of the month, the fourth of the year. So I'm going to times it by 4. So that equals 8. Okay, so then I'm going to put it into my formula. So I have $1,200 times 0.04 divided by 4, all divided by 1 plus 0.04 divided by 4 to the exponent negative 8 minus 1. Now we're going to put that into our calculator. You can use the Desmos scientific calculator, which remember shows you exactly what it is that you're doing. I don't have that linked here, but maybe I will another time. And so you're doing 1,200 times 0.04 divided by 4, divided by, you need to use brackets to make sure you're doing it properly. Open bracket, 1 plus 0.04 divided by 4, close your bracket, to the exponent negative 8, take away 1, and close your bracket again. And I have a negative answer. So that doesn't seem to make sense. All right, let's see. Let's do it on Desmos, because that is going to see where I went wrong. So again, you want to look at when you have these sorts of questions, knowing what you're expecting is really going to help you. So I got a negative answer. I made a mistake somewhere along the way, because that doesn't make sense to have a negative payment. So we're doing 1,200 times 0.04 divided by 4 all divided by I didn't put brackets on it, so it's not doing it where I want on Desmos. All divided by plus 0.04 divided by 4 to the exponent -8. See, this is where you can see in your calculator. I want to let me do negative. Oh, I'm having bad luck today. You can see on my calculator how things aren't lining up, and which is why we can get the amount. I did get a negative answer here as well. So it must be because I'm making a payment, but that seems strange because we weren't doing that before. So my answer because I'm making a deposit, we're going to say is $156.83. I'm not going to dwell right now on the fact that it's negative. That to me just makes sense that it's make a payment, but for some reason that doesn't quite line up. So if the question doesn't quite line up the way you're expecting, always spend time and look to figure out if you can figure out where you're making a mistake. If I use the wrong formula, we're just going to move on at this point, but I wasn't expecting a negative answer, so I should spend some more time if I was doing this for an assignment to figure out why I got a negative answer. All right, question 2. An orange peel may take 1 year to decay 10 to the exponent -1, so that's 1/10 of its original mass, right? Because 10 to the exponent -1 is equal to 1 over 10 to the exponent 1, which is equal to 1 over 10. An aluminum can may take 50 years to decay to 10 to the exponent -1, so 1/10 of its original mass. Part A, what mass will remain after 2 years if an orange peel has an original mass of 5 grams? So because I am talking about decay and I have an exponent of -1, I know that I'm talking about exponentials. So I'm wondering how much I'm going to have after my amount, so 5 grams decays, so 1/10 over 2 years. So I could also write that as 5 times 10 to the exponent -1 to the exponent 2, or I can write it as 5 times 1/10 to the exponent 2. So if I do that on my calculator, so 5 times 1/10 to the exponent 2 is 0.05. So after 2 years, we have 0.05 grams left. So part B, what mass will remain after 100 years if a metal can has original mass of 16.5 grams? So again, I have 16.5 is how much I'm starting with. So I'm going to times that by 1 over 10, 1/10, or 10 to the exponent -1. And now I need to figure out what my exponent is. I want to say that it's 100 because that's what the question says. But I know that it takes 50 years to decay that amount. So that means that I'm actually going to do 100 divided by 50 because my half-life is 50. So, or my 1/10 life is 50. And so that means I need to divide my total number of years by 50 to figure out how much it's going to change at this rate of 1/10. So I have 16 times 5 times 10, 1 over 10, and 50 divided by, 100 divided by 50 equals 2. So that means that my exponent is now just 2. So 16.5 times 1/10 to the exponent 2 is going to be 0.165. So after 100 years, we still have 0.165 grams of can left. And that's how you do a question like that. So that's an exponential question. All right, number 3. Barb plans to invest $10,000 in a term deposit for 2 years. She has 3 choices. Which plan should she choose and why? So because she's investing, we assume that she wants to earn more money than less money. So that's going to help us understand which plan she should choose, because our goal should be earning the most money. So we have plan A, which is 6.8% per year, simple interest. Plan B, which is 6.2% per year, compound semi-annually. And plan C, which is 6.0% per year, compounded quarterly. So because we're comparing simple interest and 2 different ways to compound, we know we're going to need to use our simple interest and a compound interest formulas. And we have to see that because she's investing just one time, that makes sense. We would use our other formulas if she was making multiple payments, but she's only investing one time, one amount. She's going to put it in that account and it's going to sit for 2 years. So we use our simple interest and our compound interest formulas. So I like to make sure that I'm organizing my information really clearly so that I don't get confused. And so whoever's marking my work doesn't get confused. So I'm going to say plan A is over here. And this one is simple interest. So I know that my formula is going to be I equals P R T. I is the interest, what we're looking for. P equals $10,000. That's how much she's investing. R is equal to 6.8%, so 0.068. And T, our time, is equal to 2 years. So I equals PRT is going to be 10,000 times 0.068 times 2. So then we're going to calculate that, 10,000 on our calculator times 0.068 times 2 gives us $1,360. So that's how much interest you would earn on plan A. Okay, plan B. Plan B is 6.2% per year compounded semi-annually. So this is a compounding question. So that means that we're going to be using the formula A equals P times 1 plus R over N, all to the exponent NT. So A is what we're looking for. P, our principal, is still $10,000, how much she's investing. R, our rate is 6.2%, so 0.062. Our N is compounded semi-annually, so that's twice a year. So our N is 2. And our T is also 2 because it's 2 years. So A equals 10,000 times 1 plus 0.062 divided by 2, all to the exponent 2 times 2. So that I'm going to do in my calculator. You can do, if you want to do the division first, if you want to do it in more steps, that is totally fine. I'm just going to do the majority of it in my calculator. So that equals 11,298.86. Just looking at my place value wrong. Okay. So then let's look at plan C, because we're comparing all 3. So plan C, we're compounding quarterly. So again, we're compounding. So that means that we are using A equals E times 1 plus R over N to the exponent NT. And we need to figure out what our variables are. A is what we're solving for. P is 10,000. R is equal to 6%, so 0.06. And we are compounding quarterly. So quarterly means times 4 times a year. So N is 4 and T equals 2 because it's for 2 years. So A equals 10,000 times 1 plus 0.06 divided by 4, all to the exponent 4 times 2. So again, I'm putting this into my calculator. So I have 0.06 divided by 4. It's like I'm doing Bedmas. So plus 1 to the exponent 8, because 4 times 2 is 8, all times 10,000 gives me $11,264.93. Okay, so now we want to compare to see which one is our best. For plan B and C, we have the total amount that she's going to earn in the end, but for plan A, we only have the interest earned. So it's going to be really useful for us to compare these three, is to find out what the total amount is. You could also find out the interest earned from plan B or C, but I'm going to do it so that we know how much we have in total at the end, because then I just have to do one opposed to having to do twice for plan B and C. So the total amount for plan A is our principal plus our interest. Well, our principal was $10,000 plus our interest, which is $1,360, which means that we have $11,360. So plan A, at the end of our 2 years, plan A is equal to $11,360. Plan B is equal to $11,298.86. Plan C is equal to $11,264.93. So I would have assumed that our compounding amount would have been better because we know that compounding generally earns us interest faster. But here at the end, my plan A earns me the most. So having the highest interest rate, because it's for a short period of time, means that plan A earns us the most money. So I would advise Barb to take plan A. That's why you can't just assume. You can't just assume based on what the interest rate is, or whether it's compounding, how often it's compounding, which one to choose. You have to do all the calculations to really compare what's going to happen. And this is how places trick us, is because we make assumptions and we don't actually do the math, and then we don't have all the information. So I would advise Barb to have plan A because it earns the most money. That's how I answer my question. All right, question 4. Determine the cost of fuel required to drive 15,000 kilometers at the fuel consumption rating of 5.2 liters per 100 kilometers, an average cost of fuel being $1.68 per liter. So this is a fuel consumption question. So we remember that in order to calculate the cost of fuel, we need to figure out how much fuel was consumed, and then we multiply that by how much it costs, how much fuel consumed times the cost. So for step 1, we're going to figure out how much fuel is consumed. And we do that by taking our how much we drove. So we drove 15,000 kilometers, and we times it by our consumption rate, how much our vehicle consumes. So that's 5.2 liters per 100 kilometers. So in order to calculate that, we do 15,000 times 5.2 divided by 100, and that gives us 780 liters. So that's how much gas was consumed over that 1,500 kilometers, 780 liters of gas. So step 2, or fuel, we're figuring out the cost. So again, I like to write out my different steps to keep myself organized. As you can see, my writing isn't super neat, but having my information organized means that it's easier to understand what I'm doing, I hope. I don't have perfect elementary school teacher writing. I've got messy high school teacher writing. So to figure out how much it costs, we do our liters, how much we consumed. So 780 liters times how much it costs per liter. So it costs $1.68 per liter. So 780 times $1.68 is equal to $1,310.40. The calculator is just going to give you 1,310.4. We put on the 0 because we're talking about money. So we're talking about 40 cents, not just 0.4. We need those 2 decimal places for money. So therefore, fuel cost is $1,310.40. As you can see, you don't have to write super detailed sentences. You just want to make sure that you're answering the question so that I know that you know what you're doing and what your numbers mean. All right, number 5. Graph each relation by finding the x-intercepts. Okay, we haven't graphed in a while. So finding the x-intercepts, so finding where y equals 0. So part A, we have y equals x minus 5 in brackets times x plus 3 in brackets. So we know that if we're finding our x-intercepts, that means that that's when y equals 0. So we're going to substitute it in 0 equals x minus 5 all times x plus 3. And we know from that the only way that x minus 5 times x plus 3 can equal 0 overall is that x minus 3 equals 0 or x minus 5 equals 0 or x plus 3 equals 0. So x minus 5 equals 0 only happens when x equals plus 5, and x plus 3 equals 0 only happens when x equals minus 3. So we have found our zeros or x-intercepts. So now I can graph those. I can say, okay, well, x equals 5. So I look on my graph and I go 1, 2, 3, 4, 5. That's where my parabola is going to cross my x-axis. And then it's also going to cross at -3. So 1, 2, 3, negative, it's going to cross there. So I can dot my other axis. We didn't spend any time to how to figure out how to graph this from our lesson, but we know our vertex is going to be about halfway between those. It's going to be exactly halfway between those. And then because it's positive, it's going to be lower down. So this is just going to be a sketch because we didn't spend total time how to do this. But then you can see that your graph, if your vertex is halfway between and below, then your graph's going to look something like that. Okay, now we have another one. So we're also we're graphing by finding the x-intercepts. So y equals -3x squared minus 15x. Okay, so first we always remember this time we need to factor. Last time we just could solve, but here we have 0 because y is going to equal 0, -3x squared minus 15x. So this time we need to factor. We look at our things and we say, okay, we have a -3 value in front of our x. So we want a common factor first. We always check to see if we can common factor first. This time, if we look at our terms, -3x is common to both of our terms, actually. So I'm going to factor out -3x. So what am I left with? So I am left with x. So -3x times x would give me -3x squared. So that's good. And then my second term, what times negative 3x gives me negative 15x? So that's going to be plus 5. Plus 5 times negative 3x equals negative 15x. So that's a common factor. I can't factor any further than that. So I'm actually done. So I say, okay, well, I know that if I want this whole thing to equal 0, either negative 3x has to equal 0 or x plus 5 has to equal 0. So negative 3x equals 0. That only happens, negative 3 times x only equals 0 when x equals 0. And x plus 5 equals 0 only happens when x equals negative 5. So again, we found our x-intercepts or our zeros. So when x equals 0 is one of ours. So one of our dots is right on our origin, and x equals negative 5 is our other one. So again, we think about, okay, well, it's going to be this time we have a negative 8 value. So that means that we're going to be opening down. And about halfway between 0 and negative 5 is about negative 2.5. So I'm going to guess it's somewhere kind of like this. Again, we don't know how to graph it exactly, but we can then get a rough sketch of that it's opening down, and it looks roughly like that. Okay. Number 6, you want to be a millionaire by the time you are 60 years old. If you invest $20,000 on your 18th birthday at 18% compounded semi-annually, will you meet your goal? If not, what interest rate would you require? All right, so this question, you're investing $20,000. You want to be a millionaire, and we're trying to figure out if that's going to work. You're only investing one payment, right? It only says that you're investing $20,000 compounded semi-annually. So it's only happening once. So this is a compound interest question. So A equals P times 1 plus R over N, all to the exponent NT. And we have A. We're going to say that we're looking for our A. Even though we know that we want it to be $1 million, we're going to say that we're going to find out what it is. So if we invest $20,000 as our principal at a rate of 0.088% for how long? So our N is semi-annually, so we're doing it twice a year. Semi-annually means twice a year. And our T, how many years? So if we want it by the time that we're 60 and we're starting when we're 18, right on your 18th birthday. So that's going to be a total of 42 years. So we have in our formula, A equals $20,000 times 1 plus 0.08 over 2 times 2 times 42. So 20,000 times 1 my 20,000, having some calculator issues, times 1 plus 0.08 divided by 2, all to the exponent. 2 times 42 is 84. So that is going to give us 539,310 cents. So is that $1 million? Nope. So it doesn't work. So you won't meet your goal. At 8% interest rate. So if we're trying to find out how much what interest rate we would need, we're going to do it again. But this time we know that our annual amount, or how much we want, is $1 million. We're going to use that $1 million. Make sure we have enough zeros. Our principal is still 20,000. That's how much we're investing. This time we're looking for our rate. So we're looking for our R. Our N is still 2, and our T is still 42 because we're still doing it over the same time period. So we have A equals P times 1 plus R over N, all to the exponent NT. And so this time we're putting in 1 million don't have enough zeros, equals 20,000. 1 plus our rate. That's what we're looking for. So we're going to leave that as R divided by 2 times 2 times 42. All right, I'm going to write out my steps this time, which I haven't been doing. I've just been doing the calculation because it's been straightforward. So here, because we're isolating for R, we need to find R. So we have 1 million, and we're going to divide it by 20,000 to cancel off the 20,000 that we were multiplying it by, equals 1 plus R over 2 to the exponent. 2 times 42 is 84. So 1 million divided by 20,000 is, oh, I multiplied it on my calculator. I just want to make sure that I do it right because I'm having a day, is equal to 50. Is equal, so 50 equals 1 plus R over 2 to the exponent 84. So now remember, in order to do this, we need to do in order to cancel out your 84th exponent, we need to do the 84th root of 50. And that's something that we do on our calculator because I have no idea what the 84th root is. So you have to look on your calculator and figure out how you put it in your calculator. So I put in 84 and then I press my nth root button and then put it in. And that's going to be 1.04767 equals 1 plus R over 2. So I'm going to leave this in my calculator, and now I'm going to subtract 1 from each side. Cancel off that 1. So that's 0.04767. And then I'm going to times that both sides by 2 to cancel off the 2. So then that is 0.0953 equals R. So we want, this is our rate, right? So what interest rate would we require? So we would times that by 100 to get our, so it would be 9.53%. So you would need 9.53% to earn $1 million. And that's how we do that kind of question. All right, question 7, factor the following. We haven't done a lot of factoring, so let's do a reminder. Remember what this is about. So A, we have x squared minus 4. So this one's tricky because it looks like we only have 2 terms, and we need to remember that we need to times to be our second term, and our constant term, and add to be our middle term. But we don't seem to have a middle term. So if we don't seem to have a middle term, really what that means is that we have 0x. So we have x squared minus 4 is equal to x squared plus 0x minus 4. So now we can say, okay, we're looking to see what numbers times to be -4 and add to be 0. So our factor pairs of -4 are -2 and 2. They're our only factor pairs. There's no other ones. So let's see, do they equal, you add them together, they equal 0? -2 plus 2 equals 0. Perfect. That's what we needed. So we know that we're going to have our 2 brackets with x in our first spot. And then our first term is x minus 2, and our second is x plus 2, or the opposite. And there we go. That's how we factor that one. So again, we have so x squared minus 100. We have the same thing. So we have x squared, we're going to say plus 0x, that's our middle term, minus 100. So we know that we want times to be -100 and add to be 0. So what are our factor pairs of -100? So we have 1 and -100. We have -1 and 100. We have 4 and -25. We have -4 and 25. We have 10, and negative 10. So 1 negative 100 is going to multiply to be negative 100, but it's going to add to be negative 99. So that doesn't work. 4 and negative 25 is going to give us negative 21. So the 4 and 25 pairs are going to work. 10 and negative 10, that's 0. So that's going to work. So that means that when we factor, we have x plus 10 and x minus 10. Okay, so now we have x squared plus 25. Okay, so we still have two numbers. So we know that we have x squared plus 0x plus 25. So we know that we're timesing to be 25 and adding to be 0. So what are our factor pairs? So 25, we have 1 and 25. That's, well, I guess we have negative 1 and negative 25. That could also multiply to be positive 25. And then we have 5 and 5 and negative 5 and negative 5. So 1 times 25 is going to give us 25, but that's 1 plus 25 gives us 26. So that doesn't work. Negative 1 plus negative 25 gives us negative 26. That doesn't work. 5 plus 5, that gives us 10. And negative 5 and negative 5, that gives us negative 10. So we have to think. So none of the factor pairs that we have works. Are any there? Is there anything that we missed? Nope. So this question is not factorable. We could solve it a different way. We don't have the skills yet, but sometimes you have questions that are not factorable, just so you know. And then we have our last one, x squared plus 14x plus 49. So we have our terms. So we're timesing to be 49 and we are adding to be 14. So our factor pairs. So we have 1 and 49, negative 1 and negative 49, 7 and 7, and negative 7 and negative 7 gives us 49. So then we want 14. Well, I know that 7 plus 7 is 14. We want positive 14. So that means we have positive 7 plus positive 7. So we're going to have x plus 7 times x plus 7, which if you wanted to, you could say is x plus 7 all squared because we have the same thing twice. You don't have to write it that way, but you could if you wanted to. All right, and there's some factoring. Raven deposited a monthly amount of $1,175 in an RSP account that pays 5.8% per annum, compounded monthly. How much will they have after 15 years? So this is an RSP question. So we know that we're contributing to an RSP and we're looking for the final amount. So that means that we're using the formula A equals R times 1 plus I exponent n minus 1 all over I. So our A is what we're looking for. Our R is 175. Our I is 0.058 because it's 8% divided by 12 because it's compounded monthly. And our N is 15 years times 12. Got to do this quick to get it into our time. So 15 years times 12 is 180. So we put it in. So we have 175 times 1 plus 0.058 divided by 12, all to the exponent 180, take away 1, all divided by 0.058 divided by 12. So we have 175, then we're just putting it into our calculator. We're hoping our calculator doesn't cause us trouble. Sometimes it does, just because we're rushed. So we get, if we calculate that, we get $347.46, which would be the payment. All right, we are out of time. We managed to squeeze that one last one in. So lesson 2 is complete. Feel free to submit your questions, your lessons. As always, contact me if you can. And if you need questions, have a great weekend. Which